I'm sure we all know that approximately 65% of our body mass is water and that about 70% of the surface of the Earth is covered by water. So it's obvious to us that water matters. But why? What makes it so special? The truth lies in the bonding between water molecules. As I'm sure we all know, water molecules consist of one oxygen atom and two hydrogen atoms. You know what electrons are, right? Well, oxygen and hydrogen atoms form covalent bonds, which means they share an electron pair between themselves. Now, different elements attract electrons with different strength. This property is called electronegativity, and the more electronegative an element is, the more strongly it attracts electrons to itself. And now, as you can see, the electronegativity value for oxygen is 3.44, while for hydrogen it is only 2.2. So the more electronegative oxygen atom attracts the shared electron pair to itself more strongly than the hydrogen atom does. Electrons are negatively charged, right? So the oxygen atom, upon attracting the electron pair to itself, becomes slightly negatively charged. And at the same time, the hydrogen atom, from which the electron pair has been pulled further away, becomes slightly positively charged. And this is exactly what makes hydrogen bonding possible between water molecules. You know, opposite charges attract, right? So the slightly positively charged hydrogen atom of one water molecule is attracted to the slightly negatively charged oxygen atom of another molecule. Now you might ask me, why is this so important? The answer is very simple. Hydrogen bonds are very strong and thus they require a lot of heat energy to overcome and are responsible for water's abnormally high boiling temperature. According to trends in the periodic table, if it wasn't for hydrogen bonds, water would have a boiling temperature of as low as -80 degrees Celsius. So all the water on the Earth would have boiled, which would have obviously been disastrous for life on Earth. That's not all. Usually, substances are more dense in their solid state than in the liquid state. But this isn't the case with water, which is denser than ice. The reason behind this is that when water freezes, the molecules become arranged in hexagonal structures held by hydrogen bonds with far more empty space between the molecules than in liquid water. And this means that in the winter, lakes and rivers do not freeze entirely. Instead, the surface of the water freezes, and then since ice is less dense than water, it just floats on the surface of the water, acting as an effective insulating protective layer from the outside cold. And this means that fish and other organisms living in the water can survive the winter even if the temperatures outside the water are far below 0 degrees Celsius. And this is why water matters.